Okay, folks, chapter 5 is about data, sources of data, and how we deal with it, how we get it, what type it is, where it comes from. And so, pretty straightforward stuff. I kind of had a different perspective as far as doing the little lecture today, a little bit more interactive. I don't generally lecture as much in class as I kind of have been doing via the online environment here. And so I thought what I would do is provide some examples and walk you through those and see if that maybe helps clarify things a little bit as opposed to just kind of going over what you're learning in the text. So we'll get started and hopefully you can give me some feedback as to whether you like this or not. Our first set of examples comes from data sources and data settings, data collection settings. And just because of the limitation of the software that I'm using, if you can kind of stay with me as we go down through the bullets, that would be helpful. I think that would probably maximize what you get out of this presentation. So what I've done here is given you examples of data, and what I'm hoping that you'll do is read the first one and tell me what type of data or what data source you think that is. So I'll give it a couple seconds. And if you said text for the first bullet point, you were right. Pre-existing texts. Most of those we wouldn't have to go to necessarily an archive as they discussed in your textbook. But if we wanted to see Camel cigarette ads from the 1950s, we might well have to visit an actual physical archive. You can also think about archives as things that are online. So the whitehouse.gov would have Barack Obama's speeches from 2004 to 2010. So we could think of that as an archive as well. I also put the anti-smoking advertisements and the Instagram photos in there just to kind of reinforce the lesson about what a text is. All right, let's do the second bullet. Okay, the second bullet, if you said direct observation, then you're correct. You're actually watching couples in a public park. Maybe you're looking for signs of affection. Maybe you're looking for signs of conflict. If you're viewing a speech in a public speaking course, then you're probably looking for some specific delivery criteria, some specific organizational criteria that you might want to evaluate or measure in some way. If you said in the field, as far as the setting for watching couples in a public park, that's correct. And viewing a speech in a laboratory or viewing a speech in a public speaking course could be a laboratory, it could be a field. If it's a public speaking course constructed purely for the sake of research, then that's probably a laboratory setting. If it's a public speaking course that you're sitting in and trying to measure effective delivery, then that would be a field setting as well. All right, let's do the third one. And if you said self-report for the third one, you were correct. We can get data by asking people to give information about themselves. All right, the final one. And some of you may be using the process of elimination. That's you. Don't cheat. Cheating is not allowed. I'm, of course, joking. My text message is going off here. Life is beautiful. Other report would be the answer to the last one, and that's when you answer questions about somebody else. In our first example, you're answering questions about your significant other. In the second example, you're actually answering questions describing something about somebody else, and so that would also be the report as well. Hopefully that clarifies through the use of examples. Data sources and settings for data. We're going to go next into how we actually go about gathering data. How do we determine who participates? Okay, so to make this a little easier, I've broken this out to random sampling and non-random sampling initially here. And so the first one, we're going to look at different types of random sampling. All of these are random samples, but they're different kind of varieties or different flavors, if you will. So a random sampling method means that each person in the population has an equal chance to participate in the study or be a part of the sample. So a population is everybody that you're trying to study, and a sample is a group of people that you select that represents the population. So if I'm studying romantic relationships, my population would be anyone in the world that is in a romantic relationship. And so in order for me to use a random sample in that context, I would have to have access to every person in the world that's involved in a romantic relationship, because random sampling requires that each person has an equal chance to be selected. So let's take a look at our first bullet point. Randomly select student number 1560 and then select every 20th person. So if I were conducting a survey of JMU students and I randomly selected the student number 1560, and from there I selected every 20th person, what would that be? Systematic with a start. That's correct. So what we're basically doing is we're still being random, because we could have picked the first person or the 500th person or the 10,000th person. But from there we would go every 20th person. So each person does have an equal opportunity. So long as how we chose the first person is random, then we're in good shape. By the way, it's very awkward to go, what would you say for that? And there's no one actually to respond. So this is kind of odd, me staring at the monitor on my computer waiting for quote-unquote participation. But I think it works well. All right, bullet point 2. JMU students are my population again. I'm going to segment JMU into races and religions. And then I'm going to randomly select from each segment, meaning each set of races and religions, to be representative of the JMU population demographics. What type of random sampling method would that be? If you said stratified, you are correct. Stratified tries to get a representative sample across demographics. All right, and the last one, use a random number generator to select 1,000 JMU students from the population. Okay, that is your basic, simple random. You're just assigning each student a random number, and from there, we just pick 1,000 of them. Again, we pick them randomly. Simple random. So that concludes the random sampling, and next we'll move on to non-random sampling methods. As opposed to random sampling methods, non-random selection techniques do not ensure that each person has an equal opportunity of being selected. In fact, they may be intentionally removing some or only including specific ones, or it may just be a result of easiness. But the sample doesn't necessarily represent the population in a perfect fashion like it does when we use random sampling. So, same process that we did on the random sampling method here. If I am deploying a survey via Facebook and asking your friends to share it with their friends to take the survey, what non-random sampling technique am I using? If you said network or snowball, that's correct. So in those, we distribute a survey and ask other people to forward it along. You can get a lot of people very quickly doing that, if you have friends. All right, number 2, or the second one, asking students in 280 to participate in a survey for extra credit. Some of you have done this many times in your SCOM classes, and if you haven't, you will. And we call this a convenience sample, because it's convenient. That made me laugh. Okay, last one. You're studying online instruction, so you only select teachers that teach online courses to participate in your study. And for this one, we would be purposive. We're interested in a specific portion of instructors, and so what we're actually doing is intentionally segmenting them, and maybe just that are teaching online classes right now, as opposed to they have training in online instruction or any number of other things. So network or snowball, convenience, and purposive. Our next set of examples to talk about is conceptual and operational definitions. The conceptual definition is what you would generally think of as a dictionary or theoretical definition. An operational definition has to do with how we're actually going to measure the conceptual definition. So, our first bullet point here, trust is keeping commitments, being honest in all communications, and not taking advantage. What you should ask yourself here is this something that would come up in a theory or in a dictionary? Or is this something that would allow me to measure the variable at play? And the variable in the first bullet point is trust. Trust is the variable here. And so that would be a conceptual definition. All right, the second one, the Thomas Kilmann conflict mode instrument. If you're thinking in your head, instrument, what does instrument mean? An instrument, a survey, those are the same sort of things. An instrument can be a survey, it could be a questionnaire that you perhaps ask people to respond to in a focus group. And so again, this is not something that we would find in a dictionary or in theory. This is how we're actually going to go about measuring conflict mode or conflict management. All right, our third one. Effectiveness in speech is the ability of a speaker to successfully persuade his or her audience to comply with the goals of the speech. If you're thinking automatically theoretical or conceptual definition, you're right. I would encourage you to stay focused on that bullet point and think about how would we measure that? How would we operationally define this? And if you look down to the next bullet point, you'll see how I came up with an operational definition. The number of people purchasing a new product after a speech. So obviously in this context, the compliance we're after is purchasing a product. So I am operationally defining effectiveness in speech by saying I'm going to count the number of people that purchased a product after you gave a speech. You might be able to come up with many other definitions of effectiveness in speech, and that's fine. Conceptual definitions exist in any number of ways, and operational definitions also exist in any number of ways. And so what's important is that we have a rational, thought-out, grounded explanation and justification for why we're defining the things that we're defining in the way that we're defining them. And I'll let you take a look at the other two maybe on your own and try and figure out which one is a conceptual, which one is an operational definition. The last slide of this presentation has to do with levels of measurement. You can kind of think about this as the type of data that we get based on the type of question that we ask. So there are four types of data, four levels of data, levels of measurement. I'll say it correctly eventually. Nominal, ordinal, interval, and ratio. And they are in kind of order of mathematical sophistication. Nominal being the most simple, ratio being the most complex. So nominal data is categories, just simply categories. And so we might ask a question about race, religion, or political affiliation and give you options of every potential race, religion, and political affiliation that we could think of. If I ask a question that says that says political affiliation, and I say Republican or Democrat, I have violated substantially the assumptions of nominal levels of measurement. Those assumptions are that the categories are mutually exclusive and exhaustive. Mutually exclusive means you can't be in both. It's one or the other. So Republican and Democrat, that would make sense, it's fine. But it's not exhaustive, meaning there are plenty of other political affiliations besides Republican and Democrat. Independent, libertarian, Green Party, any number of things. And so my categories must be mutually exclusive and exhaustive. If you take a look at table 5.2 in your textbook, you'll find a great example of nominal data. The next type is ordinal, and we have categories again here, but they're ranked, but with no indication of magnitude or space between the rankings. Table 5.3 has a great example of this. So we could ask you to rank your top 5 favorite foods. And let's say your number 1 favorite food, I'll just do this for myself. I think somebody asked this. Number 1 favorite food is sushi. Number 2 favorite food is my mom's lasagna. Number 3, let's say chili. Number 4, salmon. And we'll say number 5, I don't know, ice cream. So you might have kind of been able to figure this out as I was going through. Number 1 and number 2, pretty close together. I like sushi, I like lasagna. I was able to rattle those off quickly. I don't remember what number 3 was. I don't remember what number 4 was. 4 was salmon. 5 was ice cream. So what we have here is a situation where number 1 and number 2 are pretty close. I like sushi, I like lasagna. Lasagna to number 3 is a far distance. So ordinal data doesn't give us an indication of the spacing between our categories. And that's the weakness there. The third type is interval, and this is the type of data that you're probably most familiar with from your classes that you've taken in communication studies. We have equally ranked spaced categories with no absolute zeros. Likert scales and semantic differential scales are both types of interval level data. The book talks about unidimensional and multidimensional variables here, and we'll talk about that later in our time together. So just kind of read over that, familiarize yourself with it, but don't spend a ton of time on it. I'm not going to walk through a bunch of examples of interval level data here because the textbook does such a great job with it. So take a look at tables 5.4, 5.5, and 5.6. The last type of level of measurement is ratio, and we have equally ranked categories with an absolute zero. This is used very frequently in science, such as temperature, height, weight, those sort of things. But we can also use it in communication. For example, the number of minutes a professor spends behind a podium in a classroom would be a ratio level of measurement. It's possible that the professor does not spend any time at all behind a podium, and so there would be an absolute zero. That absolute zero means there is a lack of something. It does not exist. So there's zero time. There is no time where a professor spends behind a podium. And we could go all the way up through, I'm sure you have professors who stand behind a podium from the moment they walk in to the moment that they dismiss class. But we would maybe measure that in minutes, and the difference between 1 minute and 2 minutes is exactly the same. Okay? So that concludes levels of measurement, and that actually wraps up Chapter 5. Hopefully this was helpful. Please give me some feedback as far as the example structure to this PowerPoint in comparison with the PowerPoint presentations that we've done for the other chapters. Have a great day.